Okay, so two things on my mind today. I think I want to... What's tough is it's hard to test cases where the game might crash. So I think I want to just kind of play around and see if we can't make it crash for some reason. See if we can make it crash for some reason. Well, we're doing okay. I don't exactly know what to test. I know we crashed once when we were testing something. I think it had something to do with a high stack amount. I don't exactly know what we should try to enforce a crash. I don't know what to try, because as we've been adding features, we've been kind of testing it to try to find any potential crashes. Right here, every stone here's like a little bug in the sense that I thought we fixed if every space is occupied. So every space is occupied, yet we're in a move type place, but we can't actually place anything because there's no empty grid, but we could move a stack in our control. So that's not like a game-breaking bug, it's just I thought we had fixed that. I thought we had fixed that by saying if we if everything is occupied or something. Let's see. I guess we aren't checking that. And then it also comes down to how many things do we want to ask on a frame-by-frame basis. Because if we go to add something at the top of our update function here, like, hey, cycle through all the grids, and if they're all occupied, then switch us from a move type place to a move type move, which is totally possible, but we'd be doing that every single frame no matter what, which would be really kind of wasteful. But we would have to kind of ask it at the very least anytime stones change. So anytime we go to change the player, maybe we do that. So anytime we change the player, we cycle through all the grids, check for occupied status, and if everything is occupied, then switch us to a move type place right away, because you can't place a stone if there's already an occupant on every grid. I'm not so sold on adding that. I think I'm not too sold on adding that, but maybe we just go ahead and do that. So anytime we swap a player, so in our player swap grid reset function, I think it's called, let's cycle through all the occupants of our grid, and if every single one of them is true, we need to swap move type to get place. Now, there's another question in like, do we want to enforce a move type of move in that scenario? Because if we just swap it to move type move in that scenario, then pressing up or down will still swap our movement type, but we would not be able to. We would not be able to place any placement stone. I'm feeling like we just leave that out. It's not a big deal. You can't place a stone. You can't place a stone. Let me think through. Because it's partly being lazy, partly it's really not a big deal. If we had a function that would cycle through all the grids, and if they are occupied true, if every single one of them is occupied true, we would and I'm not sure, I don't know if I've ever done a function in Lua with a return value. I think I've only ever modified global variables with a function. But we would have to add something too around the switch state, like when we press up or down to switch our move type. We would only swap our move type if up or down is pressed, and if oh, look. Okay, we kind of do this. We did lock ourselves to a move type of move if our player doesn't have any stones left. So that makes sense. So maybe there's a way we can do it right here where we say, if we had a function that cycles through and returns, or it modifies like a white. No, yeah, it doesn't need, the color doesn't matter, it's just that they're all occupied. So if we had a function that just modified a variable that said all grids occupied gets true, it's like we would run that function, and then if everyone is true, then we were locked into a move type move. I think that would work, other than we have to also worry about the flow of the if statements here, because pressing up or down would change it, but we wouldn't change it if that function returns false. So let's go ahead and try this and say, if we did have the function written already, we'd be saying something like, if all, and this would be a variable, if all moves, if all grids occupied gets true, or no, we would just ask if all grids occupied, then we force our move type to be equal to move. And then we would say else if up is pressed or down is pressed, then we would also swap to a move type move. So if we ran a function, and we can run this function upon every player swap, because at the end of your turn it'll change occupant status for grids. So if we add the function that we're actually changing this variable to upon a player swap, then we don't have to ask it every single frame in a move type place. We would just ask it upon a player swap. So we have this variable called all grids occupied. We're gonna initialize it to false. All grids occupied starts off as false. And we don't want to reset it. We don't want to initialize it back to false upon a player swap. We do that for a lot of variables, but not for this one, because we actually need to run our function here. And our function would be called, all grids occupied. We learned our lesson about using a variable same name as a function, which Lua did not like. So we'll say every grid occupied is our function. This is not the function declaration. This is actually just the function call. So we would run the function, and this function needs to, under the hood, search through all the grids, and if they're all occupied, it would modify our every grid, or our all grids occupied variable. I think it's all grids occupied. So let's give us, we'll add that function right here, probably before our player swap grid reset. We'll give us a new function. That new function is called every grid occupied. Now here's where we define it, and we need to cycle through every grid of our 5x5 grid. And we would go up to 5, and including 5. And we would say if grid at this index is false, how would we do this? It would be a dot members. No, it would be a dot occupied. So how would we only return true, only modify this value if every single one is occupied? We would have to ask if it's occupied. How would we do that? If it's occupied, actually, then that's a good step, but we need to make sure they're all occupied. So if we need to actually ask if every single grid is occupied, which we are. We're asking if it's all occupied. And if it's occupied, how do we do this? Because we can't just say if it's not occupied, flip that all grids occupied to false. Why not? Because if the next grid is occupied, it would swap it back to true. So how would we bypass that? We need to maybe we ask if it's, and we're not trying to just modify this value based on the last grid that is checked in this loop. It's like such a simple problem, but I don't know how I would fix it, because it's like, part of me is just saying add a little flag that says, if it's occupied, then this little flag called so far so good. What if we call it currently all occupied? and we say if we're occupied, then currently all occupied. Yeah, how do we do this? What are we doing? What are we doing? We're using this other flag because we need to change the Boolean based on any false occupied thing. So we can start asking if it's occupied false. So if it's empty, then we know that currently not occupied would get true. Then at the end of our function here, we would say if currently not occupied, then we know that there was at least one false occupied grid, which would mean that all grids occupied would get false because not all grids are occupied. But then, does that fix our problem? Because if we are occupied, if we initialize this as false, then if we are occupied, nothing will happen and it'll stay false. So maybe instead of adding the not in here, we just say currently occupied gets false. Because I've done that before, doing a Boolean with the word not in there, which kind of defeats the purpose of a Boolean. So we're cycling through every grid. If any of those grids are not occupied, this currently occupied Boolean gets set to false. Then if we are false on that currently occupied, that means at least one of them is not occupied, then all our grids are by definition not occupied. But that means we would initialize currently occupied as true, treating it as if like, hey, let's treat it like we're occupied and we'll wait till you prove us wrong with this. Then once you prove us wrong, it'll set this to false. Then at the end of the loop, it says if that is false, then we're actually all grids occupied gets false. But the thing is, there's no thing setting our all grids occupied to true. So maybe we would say right here, we would say else. Else, if we are currently occupied, that means everyone would be currently occupied. Therefore, all grids occupied would get true. I think that would work. So let's make sure we initialize currently occupied to be true. Currently occupied is true. We start off as occupied, but then every player swap will run this function, and this function will turn that Boolean false if there's any non-occupied spot in our grid, and if there is only occupied spots in our grid, then that Boolean gets true. So now we just need to use this function at the end of every player swap. So in our player swap grid reset, we're actually going to run the function, which we already typed here. We pre-typed it. So as long as we're doing that, it should be working correctly. Because, yeah, until it's a new player's turn, we don't need to really care if all grids are occupied, because the move isn't over yet. So that should work. Let's print up this all grids occupied on our debugging page. And we'll put it on debugging 3 because we might have some room there. Copy. Paste. This is all grids occupied. So all grids occupied. We're going to convert that Boolean to a string so we can concatenate it with our debug, and we offset our Y. So now let's see if on page 3, debug page 3, our all grids occupied is false. Now let's see if we occupy every grid, if it swaps to true. Here we go. So we're looking for it to be true. This isn't necessarily indicative because we don't set occupied status upon our tester populate. Yes, we do. And we do for our obstacle populate. So let's see again. Okay, occupied, true, 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 true. They're all true. So we messed up our function somewhere. So yeah, our function is just not working. Now we don't reset our board unless we press R, and we don't reset so all grids occupied would get true if our currently occupied is true. And our currently occupied starts off as true, but gets set false if there's any occupied grid after a player swap. So if any of them are occupied, I don't know what's exactly wrong. I want to say, because by the time we player swap, I think maybe we need to player swap. I think we might need to just run our update after we actually update our occupied in our player swap grid reset function, because we don't actually update dot occupied here. Well, yeah, we don't do anything to our occupied status here. We do it only upon a stone placement, so it shouldn't matter where we run this function. I don't know where we're messing up. We could either add this function every time we drop a stone, but it should be upon the player swap. It really should. Because the occupied status is locked in upon a player change. So if we're then running every grid occupied, I think the thing is, we don't ever, yeah, I think the problem is we don't ever get, we need to set our currently occupied to true right off the bat here. Because if there was at any point, any grid, at any time with a not occupied, this was getting swapped from true to false and never getting set to true again. So now that that is being set to true, I'm hoping our all grids occupied will become true. And if so, we can add our move type switch. Here's moment of truth. Failed. Still says we're all occupied. So I'm curious if we're not currently occupied, occupied gets false. Else, if we are currently occupied, that's true, which means since currently occupied is true here, it means it would be getting set false at some point in time. But if all grids are occupied, which they were, we just checked, cycling through all the grids dot occupied for equality of false, none of them would have been grid occupied false. No, all of them would have been. So we need to check this for true. Is that right? If any of them are occupied, no. I think we got this backwards. We're cycling through the grids, and if any of them is not occupied, no, we don't have this backwards. If any of them are not occupied, then we know we can't be all grids occupied. So if they are occupied true, maybe instead of this boolean or this expression, we can say if not occupied. It should be the same thing. Wait, oh yeah, I don't know. Let's see, because if we're not occupied, then we can't be occupied. Therefore, we're not occupied. But if we are occupied on every single one of them, every single grid would not set this to false. Therefore, this value would still be true. Therefore, this else would run. Therefore, we are all grids occupied gets true. Now, at a player swap, we are still doing the every grid occupied function call. So anytime we swap a player. So do we in fact use this player swap grid reset upon a placement of a stone? Well, if it's a move type place, we already added this code. Actually, yeah, if this code is here, we should not be able to switch into move type. Oh, we are. So, all grids occupied. Okay. Else if. Okay. No, that makes sense. But then when we click on a spot, do we in fact swap our players? Player grid. Oh, we don't. We don't. We don't run our player swap function in a move type place, which is why it's not working. I say that as if it's going to fix it as soon as I fix that, but what if I feel like there was a reason I did that. I'm remembering that there was like a reason I did that, just not remembering what. So just to be explicit here, let's go ahead and call that in a move type place if we click on a legal move, which is right here. So before we swap players, or whatever, after we swap players, we're going to go ahead and run that oopsie every grid occupied. So let's see. Okay, moment of truth. All grids occupied false. As soon as we click this, it is all grids occupied true. And now we automatically switched ourselves to a move type move, which was the bug we were trying to fix. Now the question is, if we move this into another grid, we should become all grids occupied false again, which we do. Therefore it defaults to a place, which is right. But if we click this again, we have no available moves, therefore we're in a move type place. And if we switch to a move type place, it switches us right back to a move type move. So that's looking good. Now we could go one step further and if there is if we have no legal moves, no empty spots, so we're defaulted to a move type move. If we hit down, we shouldn't play this beep sound, and we shouldn't switch to a place, because we get reset back to a move type move. So we need to do something where instead of in a move type place, when we press down, we only do this if not all grids occupied. This is actually, we would actually maybe do this here. So if love is pressed, then we would ask if not all grids occupied, then go ahead and swap. Otherwise, all grids would be occupied. Therefore, you can't swap to a move type place, because you can't place anything, but all grids are occupied. And we don't include this in this conditional because this is an or, which evaluates either or, and we can't add an and inside an either or unless we do some parentheses. So I guess we could do it, but this is fine. This should fix it. So if all grids are occupied, which they are now, we don't have a stone rendering because we only can select a stone in our control. And for this game, I'll need to probably need to set the cursor on by default. But now, if I press up or down, we're still doing it. We shouldn't be doing that. That's because we didn't do it for the other player. So we need to do that for the other player. So we'll add this same thing. If it's a move type, no, this isn't a move type move. Why is this doing that? Let me see if there's any other times we ask if we switch. That's if it's a move type move. Oh yeah, we need it in a move type move, not a move type place. Yeah, because we're not in a move type place. So this isn't where we would want that to change. So we did logical bug right there. So if we're in a move type, yeah, if all grids are occupied, go ahead, swap us to a move type move. Then if we're in a move type move, if up or down is pressed, we would say, as long as all grids are not occupied, go ahead and play that sound and swap that move type. So now Pressing up and down when all the grids are filled should not beep, and it shouldn't render that stone for 1 frame. So we switch to move type move, which is correct. And then if we press down and up, you can't even switch to a move type place. So we fixed it. And then it defaults to place if there's an open grid. And then it defaults to a move type move if there's no open grid. So that's looking like it's working. Sweet. Sweet. So we've got that. I'm fairly happy with that fix. I don't think that'll cause any bugs. And we kind of logicked our way through it. You know, we always run that function at the end of a player swap because we put it in our player swap function, with the exception of our move type place, which we manually added it for reasons that I think need to be happening. I just don't remember those reasons, so that's probably a lazy reason to not just call that function in our move type place. But I remember thinking through this before and thinking that I didn't want to do it. Didn't want to do that function call there. So okay, so I guess, you know, we got a feature down, that's good. I think I want to start building out the algorithm for our win state. I'm going to go ahead and open our notes file. And we can add some win state nodes here. So, win state. Now there's a couple ways of going through this. Just like we didn't want to check every grid if we were occupied every single frame, we don't want to check every grid and every subsequent grid for a road based on stone control every single frame. But we would want to do it every time we swap players, just like our other one here. So we can say run in move type place after placing, and run in player swap function. Therefore, we take care of any super unnecessary every single frame running that code, because we'd have to manually check 25 grids, which isn't a big deal for a computer, but we'd want to kind of be smart about it if we can. So what does a win state entail? It at least entails a stone in every column, or not necessarily a stone, a stone control of a lay stone or a capstone in every single column at least, or every single row at least, but then it needs to be a connecting orthogonal road. So this is what's tricky about it, because we need to what's hard is if we do like a branch. Yeah, that's hard. That's hard. Okay. Here, I'll try to explain why it's so difficult to do an algorithm for it. If we take out all of our testers, leaving us an empty grid, like let's say, for example, our road is from here, oopsie. Road is from here, and then this way, and then we actually branch out and go this way and this way. This direction we go this way, and that's almost a road, but then this one is actually the road. So this would be a road because we go from the left side all the way to the right side in orthogonal stone control. So the problem is if we cycle through each grid checking for the surrounding stones, we would go here first, then here first, then here, then we'd search surrounding stones, and then there's no way to we would like lose track of our orthogonal status. So I think the better way to do it is we know there's a road. If we have a stone control stone in every single road, regardless of place, or like we have to at least ensure that we have stone control in every column or every row. So this would meet that scenario because we would go through every row. We would say, hey, do we have a white stone control? Yeah, we do. 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 Okay, now it's the next step, which is checking to see if there's a road, if we are orthogonally connected. But we can't just ask every grid because it'll start here. Ensure we're orthogonally connected. Yeah, how do we check? Yeah, it's tough. Okay, so like my current thinking is like if there's one grid, oh, dang it, it gets tough. I could see like it would be easy to write, hey, if everyone in the row is a stone control, if it's a straight road, wind state, that's easy. But this is a complex pattern because it's kind of splits and only one is a real road. So the thing is, we would go through, and if the column only has one, if the column or row only has one stone control, we know that if it were to be a road, that those two stones would be part of the road. Now, then we can do a little algorithm to search every surrounding stone of those two that we know. And in this scenario, there's two, but there might be more. So it's like, oh God, I really don't know how to do it. We'd have to do, so like once we lock in, there is, just like how we're asking if there's going to be a horizontal road, every row would need a stone control of that color. We would also ask the other way, and check this out, if we ask the rows here instead of columns, sure, we have one here. Sure, we have one. Sure, we have one. Sure, we have one. Sure, we have one. And that's true because we do have a road up here this way. So yeah, if we were to block, if we were to block this road, then here's my point. So we have, if we're checking the rows, we have a white control, white control, white control, right control, yet this is not a road. And it's not a road because the stone control at either extreme, because we would be asking, hey, is it a vertical road, or hey, is it a horizontal road? We need to check both of those scenarios. And if it would be a vertical road, then we would know that our stone control in our grid 1 would need to have an orthogonal road connection to our stone control of that row, and we know that the end one would need to at least have a stone control of that orthogonal direction, which this one does not, so we know it can't be a road, even though there's one in every column, in every row, excuse me. But since this one has no white stone control around it, then we know it can't be a road. And then what we would have to do is build out from the extremes, from our sides. We would say, okay, well, what if we had, like this, for example, what if we had this one here? But let's say black actually stopped us by moving here just to move before. So now we have a stone control of white in every row, sure. But we would be, and ignore that this is a road already, but we're checking for a vertical row right now. White has a stone control in every row, yet we are not a road because even though, this is where it gets tricky, even though our extreme case, which the end of our road would be, our stone control of our extreme case does have an orthogonal stone control of the same color, then we would ask that next frame if that one has an orthogonal that isn't the original. Yeah, this is going to be really tough to code. Because yeah, both of these have an orthogonal, so we would say, okay, it has an orthogonal connection. Let's check the next road, or the next row. And this one does not currently have an orthogonal connection, so it wouldn't be a road. But if we were to make it one and put it here, we say, sure, this one doesn't have an orthogonal connection, so it's probably not a road, but this one does have orthogonal connection, so let's check the next case. In a vertical road, the next case would be this row too. And we do have an orthogonal connection there, so we would check if we have, and this is where if it's a vertical one, we would need to check in the direction, we would need to lock in. We wouldn't care about anything above us because we know we just came from up there, so we know that road connects. Then we would say, do we now have an orthogonal connection? And we do not, so it is not a road. But if we were to have an orthogonal connection, like let's say, for example, here, I'm trying to make it as hard as possible, of a vertical road. We do have an orthogonal connection that is not the one we came from, so we would move to that one and check for an orthogonal connection there. And we do have one. We don't have one actually. Look, not where we came from. We're not checking where we came from. We're just checking any other spots. And we're not checking above us because we came from the top based on those extreme ends. I'm trying to work out this algorithm here. And then we would, for example, we would say, okay, well, what if black puts one here and now white puts one here? So we check here, we have an orthogonal, so we're say go ahead and check that one, that next orthogonal, ignoring the space we came from. And we do have an orthogonal connection, not where we came from. So does that one have a connection, not where we came from? We do over here. Okay. Does this one have one in the same direction? So we wouldn't be checking this one, but we would be checking, because we're trying to make that down vertical connection. And we do have an orthogonal space in our connection here, and we do have one here, not above us. But see, this is where it's even worse, because We do have one not where we came from. We do have one not where we came from. We do have one not where we came from, but this is other than our space. So it's like we have to make our algorithm kind of branch out. Like it can't just lock in one direction, because even though we start the road going down, we can't say it only goes down, because this one goes around and up. And it could, for example, instead of being a horizontal road as well, like let's say that this is actually, we're actually kind of blocking with black there. So this would be the, oopsie. Yeah, it's hard to plan out, but if we had a capstone here, yeah, I don't get how we would check every branch. We would need to check every branch of our possible connection. So anytime we have a surrounding, yeah, we need to check every single branch. So anytime we have more than one surrounding potential road, we need to fully explore that road, excluding where we came from, for continuous stone control, and keep iterating that until we get to the end. Because we know, yeah, I think we do this. I think we would do this basic one first, where we ask, hey, do we have stone control in every single, do we have at least one stone with stone control in every single row? And if we do, then go ahead and enable the possibility of a road. So let's check them. Let's check all the branches and make sure that we might have a road. So then we would start at, we would go grab the first road, and then we would kind of build out a branching tree of kind of toggling road control for each grid as we go. So if a surrounding stone has road control, then we do move on to that. And if a surrounding stone that we didn't just come from, which is going to be something tricky to solve, well, we just lock in a direction we came from, and then we invert it and say, hey, if the space we just came from, based on our direction, we would just not check that grid. And then we would say, yes, we have an orthogonal one here, and we have another orthogonal one not connected to where we came from. We have another one, we have another one, we have another one, we have another one, and then check this out. Right here, we have two spaces where we would have a potential road to explore. Because at this point, this could be a standing stone. This could be a laystone white. This could be a laystone white. This could be laystone white. So our road would go from here to here to here, then up here and around. So by the time we get to this square, we need to explore both possibilities, going this way and down, and we'd have to explore this way and this way, and this way and this way and this way. We would need to explore every single possibility. Yeah, that's one way of doing it. That's what I'm kind of thinking right now, is kind of define whether or not a road would even be possible based on stone control in every row or grid. Then we would start at the extremes, and we would ask, yeah, it's almost like, I don't know what we would do. I we would do. Because the other way to do it is to kind of mark, like, for example, let me just write this down and see if this makes any sense. If we write down the grids that would make a road here, what do they have in common? And what they have in common is that they are all one index away from each other, but not two indexes away from each other. So either they're one column away or they're one row away. So we would check each row. It's like, hey, does this one have a stone control? One column away or one road away? Yes, it does. So we know there could be a road here, but not necessarily there is. This is really tough. It's a really tough thing to solve. Standing stones don't count as road. Lay stones and capstones do. But I'm trying to see a pattern of the type of grid, because look, 5-2, 4-2. So that could be a road. 4-2, 4-3, so that could be a road, because there's one column difference and the same row. So it's like, I really don't know how we would do this. Other than the way of, I was thinking of doing it where we kind of just, we'd have to check. Oh my God, we'd have to check every possible direction we could go, every branch of road we could possibly take in terms of connection. We'd have to check every single possible path and ensure that each path, that it gets to the end of an orthogonal advancement based on stone control. And if it does get to the end, then we know it is a road. Jeez, man. Because we can't brute force this. We can't say if grid 2 is stone control and grid 4-2 is stone control and grid 4-3 is stone control. Because there could be so many different possibilities of a road, like this weird ass horizontal road from here to here to here to here to here. So I think the way to do it would be to determine whether or not it's possible for there to be a road. So we would ask if there's a grid in every spot. Then we would start at the extremes if we know, hey, for example, if we start with these, if there's a horizontal one, so like there's a row in each spot, so it could be a possible road, but at the extreme, this one doesn't have any orthogonal spaces, so we can rule out orthogonal road, but we can't necessarily rule out orthogonal road because there could be a white stone right here that could make a road. So if we'd have to check every extreme grid, and by extreme grid I mean if it's a horizontal lock for a road, we would check column 1 and column 5. So those are the extremes I'm talking about. And if one has no orthogonal connections, and there's only one in that column, then we know it can't be a road. But if there's another one, then we have to play out every single branch for every single orthogonal space. So it's like, once we get to here, and there's probably a smart way to do this. We could set like a branch point, because the thing is, we don't necessarily need to check, god damn it, I don't know. I was going to say we don't need to necessarily check every single branch. We just need to determine if there's a win. We don't need to find every possible win, but we need to be able to detect a win if there is one. So that should be our focus. Not trying to detect every possible win, but detect a win if there is one, which sounds like not a very smart thing, but or like there is a difference there in trying to do that. I really don't know. I really don't know how I would do it to encompass every single possible road win. I don't know how I would do it algorithmically without missing anything. So it's like we would need to set a branch point, right? So like if it's a horizontal, we're checking a horizontal lock right now. We've got an orthogonal space, so this would have to be the road if it's a horizontal lock, we know that. But then we would ask the surrounding spaces, not where we came from. And then this one, we would ask surrounding spaces, not where we come from, and we'd have to do every single branch. So it's like, there's 2 possibilities here. This is the first one. There's 2 possibilities here. We'd have to go to the first one, see that that's a dead end, because there's no orthogonal spaces in our control that we didn't already come from. Then we would go back and check the next space. That one has a space of an orthogonal direction, and this one, so we'd have to check both. Now from here, how to set this branch right, because here we came from here. Yeah, we need to set, I don't know how to do it. I'm gonna have to think more about it, because the where we came from gets complicated once the thing splits. Because we don't want to get the algorithm stuck in a loop of it saying, oh, there's an orthogonal space, 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 and it never gets to the end. So it's like we need to check. I think there is something to do with the fact that every orthogonal space will share either a row or share a column. So it's like we need to make sure that every space, every column, depending on the lock, we have a horizontal or vertical, depending on the lock type, we would need to make sure that every grid in that, every stone control in that column just be that if there is no surroundings, I don't know how to do it. Yeah, it's a harder problem than I thought. Like, I knew it was going to be tough, but it's a little harder than I thought. Yeah, I don't exactly know. I really don't know. We'll have to figure it out. But we did add a function today, which was good. That function we added was force move type move if all grids are occupied. Well, it just doesn't sound like a lot, but we had to implement a function and debug and everything. But yeah, we did it. Tomorrow we'll be continuing on and we'll be trying to figure out this win state, because it's literally the last thing we need to do other than further debug testing to see if we crash, which is just, it's hard to make it crash because it would be weird, unique scenarios where it would crash, and those are just hard to test. So we'd have to come up with some of those. But otherwise, we're literally at the last step, at least of the main part of the game. Then we can work on polishing it up, adding in those other features like keeping track of score, placing the other opponent's stones, and all of that stuff. But yeah, I'll see you guys tomorrow. We'll see if we can figure out how to tackle that algorithm.